Hello, in this video, we are going to be looking at the angle relationships that exist when we have parallel lines and they're cut by another line called a transversal. So if you notice in our diagram here, we have 100 degrees vertical to our other 100-degree angle, and then we have our 80 and 80 degrees, and that is because those angles form a linear pair. They are supplementary, and watch what happens as I move that. So as one angle gets smaller, another angle or set of angles is getting larger. So let's maybe move that back to our 80 and our 100. And if I bring this angle out, we're basically creating a duplicate copy of the set of angles that are above here. So if we look here, we've got a 100-degree angle, which corresponds to this other 100-degree angle, okay? Or this 80-degree angle corresponds to this other 80-degree angle. And that's why if I just basically take a trace of this and slide it down here, we end up with 4 angles that are congruent to each other. They're all 100s, and 4 angles that are congruent to each other. They're all 80s here. And that will remain consistent as long as those lines are parallel. So let's take a look at our diagram here. I'm going to label this line A, line B, and line C. The first thing I'd like for you to identify is what line is the transversal, meaning the line that goes through the other 2 lines, right? So the transversal is line A. So that's the one that goes through the other 2 lines. And then line B is parallel to line C in this diagram. So let's just go ahead and give a measurement. Let's just pretend that this angle here is 60 degrees. So that means there should be 3 other angles with that same measurement. Angle 3 is vertical to it, so that would also be 60. I could take angle 60, trace it down to angle 5. That would also be 60 degrees. And then we've got our 70, or angle 7 would also be 60. Now to find the other angle measurement, we could take 180, because we know together these 2 angles form a line, a linear pair. They are supplementary. We could take 180 and we could subtract 60 degrees, and that would be 120. So now we should be able to label 120 degrees here, 120 degrees, 120, and 120. All right, so in our next diagram, I'll go ahead and label each of these lines. We have line D, we have line E, and we have line F. So take a moment, name the line that's a transversal. Name the lines that are parallel to each other. Okay, and then I'm going to give you a measurement for angle 1. I'm going to say that angle 1 is 130 degrees. Please select all of the other angles that would also be 130 degrees. There should be 3 other angles. Great. And we've got 130, 130, 130. Now I'd like for you to find the measurement of angle 5. 5, 2, 7, and 4. How could we find those? Great, hopefully you took 180 and subtracted 130. And the measurement for all of those angles would be 50 degrees. Take away my question mark there. So that would be 50, we've got another 50, we've got another 50, and we've got another 50. Okay, now what I'd like to do is let's go ahead and review each of those angle relationships a little bit further. So we've got our corresponding angles. So remember, those are angles that are in the same relative position. Okay, so in our diagram here, the angles that are in the same relative position, for example, would be angle 1. If I were to take that and trace that, it is on the bottom right here. Angle 5 would be on the bottom right as well. So angle 1 And I'm going to say it's congruent to angle 5, and they are also the corresponding angle pair. Okay, our next corresponding angle pair would be angle 2. That's on the bottom, and it's on the left side of the transversal. So that would be corresponding to angle 6. We know those are congruent. Angle 2 is congruent to angle 6, or we'll just say and angle 6. And let's see. We've got here angle 3, that's on the top left, and that would be congruent and corresponding to top left. That would be angle 7. And then our final corresponding angle pair in that diagram, let's see, we haven't used green yet, will be angle 4. That's on the top right, and that will be corresponding and congruent to angle 8. So in our next diagram here, please label what angle, or please list the angle that is corresponding and congruent to A. So if I kind of tilt my head here, it's kind of on the top left. So you're looking for the angle that is corresponding and congruent to angle A out of E, H, F, and G. Okay, now match up the angle that is corresponding and congruent to angle D. Now match up the angle that is corresponding and congruent to angle C. And finally, match up the angle that is corresponding and congruent to angle B. Okay, so great. Hopefully you put A with E. You put, hopefully, B with F. We put D with H. And we put G with C. Those are the corresponding angles that end up being congruent to each other. So here, we're just solving for some of our missing angle measures. So we're going to do this one together. We know 121, that's a given angle measurement. We know our lines are parallel. We know these are corresponding, so therefore we know it's congruent. So this angle is 121. Go ahead and solve for this angle measure here. Okay, and for the next one, we've got corresponding angles still. So remember, if I take this angle, I can essentially take it and slide it on the transversal, if I can actually select it. No, it doesn't want me to select. That's okay. If I were to take that and slide it down the transversal, it should match up with this angle here. These two angles are congruent. So we should be able to say 4x plus 12 is equal to 60. And then we can subtract a 12 on both sides. We're solving for x in this problem here. So we get 4x equals 60 minus 12. It's 48. Now we're multiplying x with 4. So we need to undo multiplication. We can undo that by dividing both sides by 4. And our final solution, 48 divided by 4 is 12. Okay, now on your piece of paper, so make sure you have a piece of paper. For this problem here, you're going to write on your paper number 1 work. You are going to set up an equation to solve for x in this diagram here using 8x plus 11 and the 75. And then you're going to go ahead and answer on Edpuzzle. All right, our next angle relationship that we're going to look at is alternate interior angles. So that means on the inside of the angles, that'd be these 4, inside of the parallel lines, and on different sides of this transversal line, alternate. Okay, got to be alternate, and they've got to be interiors. So let me just shade or highlight in the interior angles here. What's going on here? Oh, my text highlighter, and I want color. That's not working. All right, well, we've got our interior angles. inside here. So we're not looking at the outside angles, the exterior. So we're just looking here. So the alternate interior angles would be, for example, 6, it's on the left side, and 4 is on the right side. So 6 and 4. And we know that those are congruent to each other, because I could take angle 6 and slide it down to angle 2, and it would be vertical to 4. So those would have to be equal to each other. Okay. And then the other two angles that end up being congruent, because they're alternate interior, are 5 and 3. So angle 3 is congruent to angle 5 because they're alternate interior. So now in our diagram here, you are going to label the angles that are alternate interior, just looking at the interior sets of angles here. So let's start with angle B. What is alternate interior to angle B? And then what is alternate interior to angle C? Okay, hopefully for B, you picked H, alternate interior, left and right side. And hopefully for C, you picked E. Now we're going to practice solving some problems based on that. So we've got our angle 50 here. That is alternate interior to this question mark, so that also needs to be 50 degrees. Alternate interior angles are congruent when we have parallel lines, and I've got my parallel lines marked here with the arrows. So take a moment, we've got 108 degrees here, and you're going to solve for the alternate interior angle to that. Great, hopefully put 108. Now let's actually try solving a problem that involves alternate interiors. So these are alternate interior to each other, which means they are congruent. So when things are congruent, we can go ahead and put an equal sign between them, just like we did in our corresponding angles problem. Now for this one, we have variables on both sides. So we want to bring all the variables to one side. I can subtract a 6x on both sides. 7x minus 6x is a 1x, or I could just say x. 1x and x are the same. And then 6x minus 6x is 0. That was the reason I subtracted it. So I could bring all the x's to the other side. And then we get x equals 11. 14 minus 3 is 11. Okay. Now you are going to use a similar method, and you are going to solve for x in question number 2, and make sure on your piece of paper you are writing out the work for this. Great. And our last angle relationship, same side interior. So we are focusing on the angles on the inside here of these two parallel lines. And this time, instead of being on alternate sides, we want them to be on the same side. So angles 6 and 3, those are same side interior angles. But this time they are not congruent. Same side interior angles add up to 180 when we have parallel lines. So I can say angle 3 plus angle 6 equals 180. The other set of alternate interior, or same side interior angles rather, are going to be 5 and 4. Those are on the same side. They're both on the right, and they're both on the inside. So I can say angle 5 plus angle 4 equals 180. So now what I'd like for you to do is identify the same side interior angles in this diagram here. So what is same side interior to angle B? Okay, and what is same side interior to angle C? Okay, hopefully for B you picked letter E. They're on the same side. They're both on the inside of the two parallel lines. And then hopefully for C you picked H. Those are both on the inside of the parallel lines here, you can notice. And they are both on the right side of the parallel line, kind of depending on how you tilt your head there. Okay. And for here, we have a same side interior angles. So we are trying to solve for this angle. Now, I know that together these angles are not equal. This is obtuse. Remember Obtuse and acute, this is an acute angle. They cannot be equal to each other. So make sure you always kind of look at it and say, well, should I be setting them equal? No, we shouldn't. So what we're going to do is we're going to take 180 and we're going to subtract 106, and that's going to give us 74 degrees. So this angle here is going to be 74. Okay, now take a moment. I'd like for you to use the same method to solve for this missing angle here. Whoop. Great, hopefully you took 180, you subtracted 63, 117. Okay, and our last problem, we're going to practice actually solving for a variable based on same side interior angles. So remember these angles, one's acute, one's obtuse, they're not equal. We're going to add them to 180. So 6x plus 15 plus 11x minus 5, let's set that equal to 180. Now, when we're solving an equation like this, I have multiple x's on the left and other constant terms. I need to combine my like terms, my x terms. So really, I have 6 of x and I have an 11 of x. So 6 and 11 altogether is 17. And then we've got a 16, or 15 rather, and a negative 5 that needs to be combined. So 15 minus 5 is 10. And then from here, I can subtract 10 on both sides. 17x plus 10 minus 10 is 0. And then I subtracted the 10 on the other side. So I'm left with 17x plus 0, or just 17x equals 170. And the opposite of multiplying on both sides by 17 is to divide on both sides by 17. So when we do that, we're going to get x equals 10. And then you're going to use the same method. Go ahead and solve for x in our very last problem. And make sure you're labeling this on your piece of paper with number 3, work.